enthusiastic. Good morning. All right. Thanks for showing up on a Friday. Some people think it's optional. It is not. Looks like the class is starting to thin out a little bit. There's this odd behavior that right after an exam, some students think it's okay to take a day off. Oh, we just took it again? But we have plenty to do today. So, I didn't put it on the screen. So today we're going to finish up chapter 2 about research methods. And then we'll move on to chapter 3. So we'll just be on the screen in a moment. There we go. Anytime. So today is the 12th, the end of the 4th week of the semester, believe it or not. We're just about at the 1/4 point of the semester. Well, we are.
Wait, I thought it's the 3rd week. Oh,
It's
is
the
it?
12th.
Yeah.
Oh, that's right. I skipped 3. I'm sorry. You're right. How did I go from 2 to 4? It's the end of the 3rd week of the semester. Thank you. The end of the 3rd week of the semester. So we're about we're not quite at the 1/4 point. I must have taken a week. Yeah, I must have taken something. Anyway, we're at the end of the 3rd week. And today we'll finish up 2 and we'll get to 3. So we should, by Monday, you should have read 2 and 3. And then we'll move on. The next exam is on the 29th of September in this room at our regularly scheduled time. The same process as last time. Okay. Any questions? Okay. So we just got finished talking about experiments. Let's just take a step back and talk about where we are. So you define the problem is the first step in the scientific method. What's the second step? Review literature. What's the third step? Yes. Formulate a testable hypothesis. That's really critical. And now we're up to what stage?
Work out a
Research design. And we got through surveys and the benefits and downsides to surveys and experiments, and now we get up to observations. So, who would like to tell us what the objective of an observation is? Why would you ever select an observation? Somebody else is looking. Well, yes, all the research designs are to collect data to eventually test your hypothesis. You are correct. But why select an observation instead of something else? Yes? Because it's in their natural environment, right. So that's one of the benefits, is that you get to test people, see people, collect data in a qualitative way in their natural environment. So if somebody, and this has happened, somebody wanted to do research about a college class, they would ask if they could sit in with us and take notes, right? And observe what all of you are doing in this natural environment. It's not like we're asking you to go into some lab and pretend like you're a student. That wouldn't be a natural environment, right? It's not like we're asking you to go to some other college or university and sit in there and, you'd be a little bit out of your environment. So it's good for observing people in their natural environment. Bless you. Is that a double sneeze? Or are you ripping paper? But the biggest challenge with observations is that you can invoke the Hawthorne effect. tell us what the Hawthorne effect is. Yes. Say the last part. To assume in what? You're on the right track. It's not true. There's a little, but you're on the right track. Anybody else? Excellent. What's the Hawthorne effect? A little bit more about the Hawthorne effect. Yes. Because they know they're being observed. People acting differently than they normally would because they know they're being observed. So a couple of things about the Hawthorne effect. The idea came from an experiment that was done in Illinois at a factory. And the researchers wanted to see if they could get more productivity out of the workers. And the way that they thought they could do this was the test stimulus that they used. I know we're talking about observations, but the test stimulus that they used was to increase the lighting in the factory. So let's say this was what we have right now is the normal lighting in the factory, and they were producing, like, let's say 1,000 units a day, just to make up a number. And then they said, well, we wonder what happens if we increase the lighting a lot, like that. So the workers came in, and all of a sudden the lighting was completely different, but they didn't say anything about it. And they waited till the end of the week, and all of a sudden the productivity went up to like 2,000 units a day. And they go, oh, look how smart we are. We just invested a few bucks in lighting, the light bulbs, and we doubled our productivity. And one of the researchers said, we're not sure, we can't be sure about that, right? We can't be sure it's the lighting. So the only way to be sure about it, and I don't want to take the lighting all the way down, but is to drop the lighting down below where it used to be. Because if lighting is the test stimulus that's causing the change in behavior, if we drop the lighting down below where it used to be, what should happen? To confirm this, yeah. Productivity should go down, right? So they dropped the lighting the next week, and what happened? Productivity went up again to 3,000 units a day. And they were puzzled until one of them said, you know, maybe we shouldn't be standing around with clipboards observing these people where they could see us. And that's what it was. It had nothing to do with the lighting, it had to do with the fact that people knew they were being observed. So when you first start teaching, so this is how I can tell you that it really takes place. So, at least from my own experience. So when I started teaching here, well, at other places before here, but when I, particularly here, when you first start teaching, somebody from the department comes to observe your class, right? You've seen it, well, if you're a freshman, you probably haven't seen it. But you will see it from time to time, not here, but in other classes, when, particularly if you have some of you might have graduates, doctoral students teaching the classes, right? They're going to get observed, most likely, and then maybe somebody else. So the chair of the department, the dean, or just another faculty member will come in, they'll, give you a little wave, give you a little wave, they won't make a big deal about it, they'll sit in the back and take notes. Well, it's subtle, but the students tend to notice it when there's another adult in the room. I mean, sometimes we're adult students, but when there's another adult in the room, it tends to get everybody's attention. And I can tell you, from my own experience, that, every class there are students who participate regularly and there's some students who almost never participate, right? The days that I've been observed, the students who never participated, their hands were going up like crazy because they thought they were being observed. And then as soon as the person walked out of the room, they went back to their normal behavior. So it is a real thing, at least from my experience. So you have to be careful not to invoke the Hawthorne effect. If you're doing an observation, you can't let people know that you're observing them because they're going to change their behavior. That's one of the risks. The other downside to observations, even though they're very effective for qualitative analysis, is that you get a lot of information about a particular situation, but it is not generalizable to other populations. So if somebody comes in and observes our class, they learn a lot about this class, they don't learn a lot about organic chemistry or French or human biology or anything like that. But it is a good qualitative way of describing what's going on and writing about it. Any questions? And again, the chapter goes into more detail about this. If you didn't do well on the last exam and you're not more prepared today, it's not going to go well this month. It's not magically going to get better. Right? And I think that everyone who did well probably was very well prepared. Okay? All right. There's a particular type of observation called an ethnography. This is a type of observation that is much more extensive, more time-consuming, much more useful. It's referred to as participant observation because it's much more complex. The observer, the ethnographer, participates in the situation. So an example would be, we just described somebody wanting to come in here and observe the class. They asked me, can I, forget about the faculty member. Let's just say some researcher wanted to come in and observe you, right? Just sit in the back and take notes. People in the front participate, people, those kinds of things, just qualitative stuff. Well, a participant observer, an ethnographer, wouldn't do that. They would register for classes, they would apply to the university, they would register for classes, they would pay tuition, they would take exams, they would be able to describe the entire experience as a participant, not just as an observer. So it could be much more expensive and much more time consuming. I'm aware of, we talked about Irving Goffman, right? His daughter, he's passed on, but his daughter is still an ethnographer, and she wrote a book in which she did an ethnography that lasted 6 years in Philadelphia. 6 years. Where she was spending time with the inner city population of Philadelphia. She wrote a book about that. Okay. Is everybody clear about the difference between a casual observation and an ethnography? Okay. All right. The one that, as undergraduates, you'll probably, I think I asked how many of you have been involved with any kind of research, and many of you will if you have not already as an undergraduate. You'll probably be using existing sources of secondary analysis. And it's the same concept, right? If you're not collecting the data yourself, you're using sources that someone else has collected. It is not primary analysis. It's not a primary research study. What's the example they gave in the chapter of this? Or a clear example? That people use data that's been collected somewhere else all the time. Anybody? I don't have my clicker. Census data, right? Census data. 350 million people live in the United States approximately. The intention of the census is to collect information about every single person. So there's a lot of information. And census data is valuable because it is free, it is fast in terms of getting access to it, and it is clean. Anybody know what clean data means? Or dirty data? Doesn't mean dirty like that. But yes?
Personal bias.
Well, that makes sense, but it doesn't have to do with personal bias. It has to do with the structure of the answers. So, if you ask the question, what county do you live in for participants? And they lived in like Rensselaer County and Schenectady County. How many different versions of spelling of Schenectady and Rensselaer do you think you get? More than one, but yeah, more than one, right? Several different. Some people would abbreviate it, some people would spell it correctly, some people would make, a slight mistake in it. So now you've got all this data that is not final, and you have to go in and clean it up. And that's a time-consuming process. You don't really want to do that. But the census cleans everything up. So all the Rensselaers match, and all the Schenectadys match, the Onondagas match, and all those kinds of things, right? So that's the benefit of the census. It's free, it's fast, it's clean, it covers a huge population, but the downside is that it's limited to the fields that are collected. So if you want to know, so if you're interested in male teenage Native Americans who live in Syracuse, you can find that information on the census, if that's what you're interested in studying. But if you want to compare left-handed versus right-handed male teenage Native Americans in Syracuse, they're not going to have that information. So now you have to either collect it yourself or you have to find something else. Right? Everybody clear about that? You're limited to what they collect. It's a lot of stuff, but if you have an interest in something else, you can do that as well. There is a particular type of existing sources / secondary analysis called content analysis. And that is just as simple as the title says. It is an analysis of content that already exists. That already exists. So we put up a lot of stuff, just don't panic, it's covered in the chapter. So it could be print media, it could be other types of writings, it could be broadcast media, it could be other recordings, it could be live situations, such as speeches and transcripts. But the one that I think would be useful in talking about for a minute, is graffiti. How in the world could you analyze the content of graffiti for a study? Yes. Right. Okay, so that's actually very interesting. So the location, is it downtown? Is it in a residential area? Is it, on a mural that they've given people, so some communities, they set aside a wall and they say, feel free to do whatever you want, but you got to do it here. Is it on the trains in New York City? That's very interesting, right? So where is it, and what is the content? So what's your hypothesis? My hypothesis might be that in the 70s and 80s, graffiti was about individuals, right? John was here, Bob loves Jane, those kinds of things, right? But now you might predict that the graffiti is more about social causes and acronyms and things like that. And that's a hypothesis. I'm not saying that that's true. But you could go back and look at pictures of New York City trains, and then you can go around and look at graffiti in other places. And you can compare them, right? So there's even something as esoteric as artwork or graffiti could be analyzed. So you go back and look at things that exist, and then you use a hypothesis, and then you collect the data. Here's an example, sort of a humorous example, I think, but here's an example of a content analysis that was done. So this guy is Troy Aikman. He is a Hall of Fame quarterback, and he also has been broadcasting on television for about 20 years. And somebody got the transcripts, I guess, of every one of his broadcasts somehow. And they analyzed the content of his descriptions of how well somebody does, their football players do their job. And over something like 20 years, they found out that he only uses 7 adjectives. He only has 7 adjectives that he uses to describe how well people do, football players do their job. And almost 40% of the time he uses that. And then he has just a few other vocabulary words that he uses. And it's not the most important study in the world, but it just shows you that you go back and you can come up with interesting findings based upon content that's been done. Any questions? Okay. Anybody caught up? You don't have to know the names that you use. It's more about the concept. Okay. So, we have defined the problem. We've reviewed the literature. We have formulated a testable hypothesis. We have selected a research design based upon budget and time and needs and things like that. And now it's time to carry out the research. So, if we have to go back and look at the original research design, that's our hypothesis, what our research question, all those things. And if we're going to do a survey, now we're going to deploy the survey. And that means if we have it on Google Forms, right, you receive those, it's time to send them out to all the email addresses that we have. If we're doing it on SurveyMonkey, we send it out in SurveyMonkey. If we have it on paper, we start handing them out. If it's an experiment, we have a date that we're going to start the experiment. If we have an observation, etc., it's time to start collecting the data. Whatever the research design you select, for whatever reason you select. And this is the stage where you will most likely deal with unanticipated problems. This is where things tend to go sideways. The server might go down. Your graduate student who's helping you out might not show up, right? They may drop out of the, maybe they can make more money doing something else and they're not going to stay with this. Whatever it is, this is where you need to have a plan B, right? I might ask that other people. Where do you need to have a plan B and a plan C and a plan D? This would be the time for it. But one way or the other, you're getting your data. And if it's a survey, for example, now you're going to get lots of rows and columns because all the people that answer, they're going to, right, it's going to be how many people answer this. Let's say 100 people answer, it's going to be 100 rows down. And how many variables did you ask? Let's say it's 10 rows across, 10 columns across, right? That's where you're going to get all this stuff. Or it's an observation, you're going to write it up. And then, once you've collected your data, you're going to interpret your results. This is where you evaluate, was your hypothesis confirmed or was it refuted? You're going to go back and answer the initial questions that you had, the initial research question, and then eventually you're going to evaluate your hypothesis. You're going to do this most likely using statistical analysis software of some type or another. For most of you, particularly if you don't have any budget, you're going to use Excel or Sheets. You can write Sheets there. It's the same concept, a spreadsheet. Bless you. But just so you know, there are more complex packages that you can use, such as SPSS. How many of you heard of SPSS? Nobody's heard of SPSS? You will, most likely, if you stay in social science. If you go on to be a professional, you You would use SAS, which is a expensive version of these statistical analysis softwares, or Logit or Stata, which are also known in the industry, similar to SAS. But the one that you will almost certainly encounter if you are going to do any kind of research here or anywhere else professionally that has become very popular and that I teach it in my research methods class is R. How many have heard of R? No one's heard of R. R is free. You can get access to it today, free. You have to know how to program, but it's much easier than it used to be. You used to have to load a lot of stuff on your computer. Now you can just go to a website and do your calculations there. You're programming there. Same place you can program for Python and other things. But R is the one that's more popular now because it is memorialized. Free. And it's pretty good. But half an hour to write one minute. So, any questions? So, excuse me, the textbook says that reporting of research findings is the last step, last stage. So then we're going to go on for stage four. You go to report your research findings. If you are an undergraduate and you're taking my research methods class, you're going to try to get college credit for it. Right? You're going to do research and you can submit your proposal or your paper, and you're going to get college credit, even in graduate school. But the holy grail, the ultimate objective of research amongst those who do this professionally is scholarly submission for peer-reviewed journals. Peer-reviewed means others in the field, other experts in the field are asked to review the studies, the submissions, and if they agree, that it is ethical and well-structured and meaningful and covers the ground, then they may agree that it should be published, although there's very strict guidelines. But if you can get published, that is the ultimate objective. That's how people get tenure, that's how they get grants, that's all that. One way or the other, you want to report your findings. Any questions? Now, again, the textbook says that's the end of the process. I believe that's the last stage that it's definitely in. Since your team showed up on a Friday, I'm going to tell you what really happens. Okay? Excuse me. The last step is repeat. Why would you repeat research? Yes?
The data might have not been accurate the first time.
Oh, I'm sorry, say it again.
Sorry. The data might have not been accurate the first time.
It may not have been accurate. That's always something that you want to validate. But somebody else might want to validate because they don't agree with you, because you were making your methods and your data sets very clear. So sometimes others want to repeat it, either because it's a compliment to you and they like what you did so much they want to see if they can do something similar, or they disagree with you. This has happened a number of times as well. Some people are skeptical about results and they want to see if they can get the same answer. But the other reason why you would repeat studies or research is because you want to do a trend analysis. How have things changed in a month? How have things changed in a quarter or a year, or in the case of the census every 10 years? So it's often important to do seasonality or or trend analysis. And this happens very often. Reports are quarterly, monthly old. So there are legitimate and valid reasons for repeating research. Any questions? No? Okay. All good research, even as good as it is, and some of it is brilliant, and you read it and you go, how could anybody ever do anything, better than this? This is the best that can be done. Even though those ethical researchers, serious researchers, will say more research needs to be done in this area because things change over time. Okay. What I'm about to say and put on the slide is one of the most important things you'll learn in college. And it is very obvious, but I would say most people who don't study this don't understand. Correlation is not the same as causation. Correlation is not the same as causation. Why not? Yes. Well, we're going to talk about the definitions of this. I'm assuming you read it. Yeah. Okay. So things may appear to cause other things to happen. Yes.
There might be a variable problem
And that's the advanced analysis, right? You could never really capture all of the possible other variables. There always could be something else that's involved. So variables, things that change, may be related to one another. They may give the appearance that they are causing the other, but they may not be directly and statistically responsible for a change in another. So a couple of examples. I have a graph to show you, but I'll give you an example verbally. The taller you are, the more money you will make. The taller you are, the more money you will make. Technically, that's true. But it's not because as you grow, you're going to get a raise at work. The reason why that is technically true is because on the average, men are taller than women. On the average. And on the average, men make more money than women. So technically, the taller you are, the more money you will make. But it's not because your height is causing you to make more money. It's a correlation. Does everybody see that? A correlation is when two variables move at the same time, but it may not be because one caused the other. So I believe the next slide is another example of how correlation may be misinterpreted. Anybody not clear about what we're talking about so far? Can you tell us what's going on here? Yes. obviously true. These are real, trends. You think there's any correlation? Any causation? No, it's a complete correlation. I don't think you can provide any evidence that the iPhone is causing people, unless it's so expensive they have no money left to even buy gum, right? And that's the only thing I can possibly think of, and I don't think that's true, right? So this could be on the news, on social media, or on the front page of the New York Times, and there are going to be people that are going to go, I knew that iPhone was causing negative things in the economy, right? And they're going to tell their friends, and they're going to not understand it because it's on a graph. And you have to be very careful about this. This is a very exaggerated situation, but a lot of times, coffee is the greatest example of this. How many times have you heard studies about coffee? Right? Coffee causes this, coffee makes you live longer, coffee makes you die earlier, coffee makes your hair fall out, coffee makes your hair stay on. All kinds of, almost every day. Almost every day you hear something about coffee, and it's almost never coffee having anything to do with it at all. But people love coffee, so if they hear the word coffee, they start paying attention to it, because they're not aware of this thing. In understanding research, you have to be able to identify the relationship between independent variables and dependent variables. The independent variable is the cause of any change on its own. The dependent variable, and there can be more than one, but we're just going to talk about it in a singular way for now, is affected by the independent variable. The dependent variable is the variable we're trying to understand. And the dependent variable is the thing that has changed. Excuse me. So, here are some examples. Here's one example. Of which you have to pick out which one is which. Time spent studying for an exam is one variable. The grade on that exam is the second variable. Who'd like to tell us which one is the independent variable and which one is the dependent variable? I think you have to hear that. Sure? Yep. Yes? Yes? Not what you said. Is that what you said? Yeah. It's okay. Yeah. Number one is the independent variable. Number two is the dependent variable. The thing that has changed that we're trying to understand is the grade. Right? I think that's what most people are interested in. So, I would love to know, given the results of the last exam, I would hypothesize that those who did well spent more time studying, preparing for the exam than those who didn't. I would be surprised if that weren't the case. Now, there's always going to be exceptions, but on the average, I would estimate that would be the case, and then we would do a full study on it, and we would collect data and look at our results. But the number one is the independent variable, number two is the dependent variable. Is everybody clear about that? Now on the next exam, I'm going to ask you questions about independent and dependent variables, but I'm not going to give you this example, I'm going to give you other examples. But as long as you understand these criteria, these rules, you should do equally well. Any questions about the relationship here? Okay. If you are going to do research in the real world, not looking at the census and saying there are more males than females in Syracuse or Native American, that kind of thing that's already been done, and you're not affecting the individuals. In fact, you don't even know who they are, right? Because the census doesn't give you individual information for 72 years. They eventually do release it, but 72 years later, well, that's another story. But if you're going to be doing research on human subjects, meaning that you're going to go out and collect the data, and it can be a survey, it can be any of the research designs that we went over, then there are special ethical guidelines that you need to observe to be, to get credit for anything that you do. If you were in my research methods class and you didn't follow ethical guidelines, you certainly would you'd get a 0. And if you were trying to submit this to a journal as a scholar, you would not be able to do that without providing evidence of the ethics that you are required to do. So, this all started, the idea that there had to be ethics involved with human research involving human subjects, really as far back as the World War II. The Nazis did just inhumane experiments on humans that were not, there was no oversight on them at all. And then, Stanley Milgram, this is not to say that the next two are equally evil. The next two were not evil, they were just unethical. So other examples are Stanley Milgram's obedience to authority experiment. You've all heard of it, you're all aware of what it is. We're going to go over it in a little more detail later in the course. That was an outstanding research project, but it was unethical. Why was it unethical? Does anybody know? We'll go over it in more detail later, but why was it unethical? Yes? Say that one more time. Correct. He caused emotional harm. Emotional and psychological harm. You can't do that. And we'll talk about that in a minute. So that would not have been approved today. So because of these kinds of experiments and Phillips and Bardo's Stanford prison experiment, where physical harm was inflicted on subjects. By the way, the interesting thing is, and you'll see this later, Zimbardo and Milgram went to high school together in the Bronx, just coincidentally. These were well-known, the last two were well-known experiments that would not have been approved today. And because of all these history of unethical research, all research institutions now, I think it's since 1972, have the oversight of institutional review. Institutional review boards exist at every educational institution. There's not just one of them. Every university, every college has their own. I've been on the IRB. It's made up of professors. But of course, it's not involving your own research. It's about other people's research. And the way it works is, if you want to do a research study, you have to apply for a certification by an IRB. And you have to disclose everything, including, did everybody sign informed consents? Is everybody in the study protected? We'll talk about the reasons. So the role of the IRB is to make sure that research conforms to ethical guidelines when dealing with human subjects. Let me be very clear about that. This does not apply if you are just doing census research and there are no humans involved, especially if you don't know who they are. This is when you know who they are and you're trying to get them to do research. Has anybody ever been involved in a research study like here or somewhere else where you were paid some money or something and they asked you some questions, or there are flyers all over the building for questions to have people participate, and they must tell you whether the IRB has reviewed. So they must conform to ethical guidelines. Researchers must acquire informed consent from everybody. Yes.
So if the IRB doesn't approve it, they still can do it, it just can't be published?
Well, no one's going to accept it without IRB approval.
Okay.
Now, can you go out with your friends and do research? Yeah. But no one's going to, you're not going to get college credit for it, you're not going to get published, you know. Now, in today's world, people can have their own, Instagram account and talk about it, but it's not real, it's not academic research. The IRB requires that researchers requires informed consent from adults, and if if you're studying children, you have to make sure you get their parents or guardians approval or consent. They must minimize invasions of privacy. IRBs must require that researchers minimize invasions of privacy. Sometimes researchers get information that they weren't necessarily expecting to get, and you have to keep it private. Researchers must minimize, researchers minimize risks to participants, including emotional, physical, and psychological harm. So it's on the slide, but you can write this down. The kinds of risks are emotional, physical, or psychological harm. So in Milgram's experiment, it was psychological and emotional harm. In Zimbardo's, it was mostly physical harm. And in, obviously, in World War II, it was AIDS. IRBs make sure that researchers protect confidentiality or ensure confidentiality. Let's spend a minute on that. Who can tell us the difference between anonymity and confidentiality? They're not the same thing. Yeah. Okay. Yes.
Anonymity is just it can be public, but it'll be discreet. So no one will know that it's you, but confidentiality is between person to person.
Okay. What are you gonna say?
I was gonna say, anonymity was like almost like a police consultant, like you consulted the police, like and if you weren't involved in crimes, but they protect you from that if you like snitch on like your friends or whatever.
Okay. So when I give you exams and give you and grade your exams, I know who you are. I mean, I don't know you personally, but I know your names. I am required by FERPA rules and university to keep your information confidential, right? But I know who you are. If I just gave out the exams because I wanted to see how a group of 120 people did on this exam, but I never took your names, then it would be anonymous, right? So anonymous is, I don't have any secrets to keep. Confidential is, I'm keeping them secret, right? Your parents ask me, if you're over 18, what's your grades? They send me an email, I want to know what my son or daughter's grades are. I cannot tell them because I have to keep it confidential. But I do know who you are. So if I didn't know, then it would be anonymous. But once I know, then it's confidential, and I can't share it with anybody. Does that make sense? Okay, we're almost done. And IRBs require researchers to avoid deception. That was another unethical part of Milgram's experiment. He fooled people. He told them, and we'll see this when we get to, I think it's groups and organizations. No, it's groups and organizations. That he told them they were coming in to test their memory, but they were really coming in to test their obedience to authority. He deceived them, and that would never fly today. But there were no IRBs. So these are all very important in any kind of research. When you do research in a class, the professor has to serve in the role of the IRB. Right? So if you're in my research methods class and you say you're going to do something, you want to do a research experiment on something, I have to make sure that you don't violate any of these things in the lease. Right. Any questions? All right, we'll let you out a few minutes early. Make sure you reach after 3. Have a good weekend.